We've got a very interesting talk today, and I'm sure we want to have as much time for questions as we can. So good afternoon, everybody. My name is Dr. Jo van Herwegen, and I'm one of the Center of Educational Neuroscience members. It's a great pleasure to welcome you at the final seminar for this year. And it's a great pleasure to introduce our final, but not least, speaker that we have in this series, Dr. Tammy Campbell. She is an assistant professorial research fellow based at the London School of Economics, and she's based in the Center for Analysis of Social Exclusion. She completed her PhD at the UCL Institute of Education, where I'm based too, so it's a great place to be, and was previously a government analyst. Before that, she worked with children and young people in London, Japan, as well as Norway, and she's an interdisciplinary researcher with the main interests in childhood and education, social, structural, and psychological processes causing inequalities, and also examining the intended, and this is what I like, the unintended ways in which policies play out. But today she's here to talk to us around little fish and big streams and how do early in-class maths ability groups and early teacher judgments relate to primary school children's later maths self-concept. So Tammy, the floor is all yours, and thank you.
Great, thank you, Jo, and thank you to Jo and colleagues for having me here. So today I am going to present to you some published work plus some work in progress, and both of these pieces of work use the Millennium Cohort Study. So the published findings that I'm going to talk about today are in the Cambridge Journal of Education, and there's also a brief based on that in my research centre's brief series. So if you'd like to know more, please do have a look at either of them. They're both open access. And as I say, I'm going to talk about findings from those papers and then some very early work in progress that builds on that previous research. So self-concept can be defined as an idea of the self constructed from the beliefs one holds about oneself and the responses of others. And why investigate determinants of math self-concept? Well, there's lots of reasons, as well as it just being inherently interesting. So firstly, there's evidence that math self-concept influences children's learning behaviours, traces of educational tracks, attainment and careers. And there are long-standing inequalities in math self-concept and in these outcomes related to math self-concept, notably by gender. So we all know about the lack of girls and women in STEM subjects and careers. And Bowler argued, if we are to understand the reasons for the underachievement of girls in maths, it must surely be necessary to interpret their actions within the context of their environment. So the published research that I'm going to talk about today explores aspects of this environment by asking four main questions. Firstly, is the maths in-class ability group within which a child is placed at age 7 related to their maths self-concept at 11? Secondly, does the judgment by their class teacher of a child's maths ability and attainment at age 7 relate to the child's maths self-concept at 11? Thirdly, do these relationships vary by a child's early concurrent maths skill, which is measured by a maths cognitive test at age 7? And fourthly, do these relationships vary by gender? So the literature on teacher judgments indicates that they influence children's self-concepts. So teachers' beliefs and judgments about pupils have multifaceted and long-term effects. There's evidence that socializers, such as teachers' beliefs, directly affect students' beliefs, such as their stereotypes and their ability self-concepts. The evidence also tells us that teacher beliefs and judgments about pupils can be biased. And this bias includes a tendency to be more likely to think that boys, as opposed to girls, are good at maths. The literature on ability group placement also indicates that it can influence children's self-concepts. So the majority of evidence over time on ability grouping suggests that grouping generally stratifies and that it advantages children placed at higher levels and disadvantages those placed at lower levels, though there is some ambiguity on the impacts of in-class grouping. The literature on so-called ability grouping also tells us that there are inequalities and biases and error in assignment to groups. And so-called ability grouping could influence children's self-concept in at least two ways. Firstly, it could influence through labelling effects. So this is where children in lower ability groups will have lower self-concept because they've internalised the norms and the messages around the group and its place, and vice versa for children in higher groups. But on the other hand, contrast mechanisms like the big fish, little pond phenomenon, which is where more highly skilled children placed in a lower group environment compare themselves to children who are on average relatively less skilled and therefore have elevated self-concept. So this research focuses on these two key potential environmental influences on math self-concept at age 11. The earlier age 7 in-class math so-called ability group that a child is placed in, and their earlier class teachers' beliefs about their judgment of maths when they were age 7. And why am I looking at both of these factors simultaneously, apart from the fact that they're both sort of feasible candidate factors? Well, these factors are interrelated. So ability grouping influences teacher judgments and teacher judgments influence ability group placement. And in their work on how ability grouping affects children's math self-concepts, Frances and colleagues talk about a snowballing prophecy where ability group placement dynamically and iteratively interacts with the environment over time, including with teacher perceptions. So I'm looking at whether early in-class maths ability groupings and class teacher judgments of children's maths each have an independent relationship with children's later math self-concept, accounting for the other. And I'm also looking at whether this pans out similarly or differently for girls and boys and for children with different measured math skills at 7. I'm just going to pause for 1 second here because I just want to sort out my screen. And in the meantime, Joe, if there's any questions at this point, that would be good.
Let me just have a look. I don't think we've got any questions yet.
Can I just check? Can you see the menu along the top of my screen?
No, we can just see your slides as if you would normally, as if they're in presentation mode.
Okay, great, thank you. For some reason, I've got the menu covering the top of the screen, which doesn't normally happen. So I'm just trying to figure out. Okay, I've made it go away. I think it's because if it has something in chat, it won't go away. Great, okay, it's gone. So now I can see my titles again.
That's okay, there you go.
Thanks. Okay, so to look at these questions, I'm using data from the Millennium Cohort Study. So this is a longitudinal national study that's been running since the year 2000 when the cohort members were babies, and it's sampled to be nationally representative. And I'm using data for children who were in England at wave 4 when they were age 7 in 2008, who have information on in-class so-called ability groups and their class teacher judgments, and who also have responses to an item at wave 5 when they were age 11 in 2012. And that's their response to a statement, "I am good at maths." And so my sample is about 4,500 children. So in the sample, 13% disagree or strongly disagree versus agree, strongly agree that they are good at maths. And this is my measure of negative maths self-concept at 11. And 16% of girls have negative maths self-concept according to my measure, and 9% of boys. And the key predictors, as I say, are the teacher's judgment of the child's maths ability and attainment at age 7 and the in-class maths ability group. So the children's teachers were surveyed at the same wave when children were age 7, and they were asked to rate some aspect of the study child's ability and attainment. And they were told that each area is subdivided into 5 categories. Insofar as your professional experience will allow, please rate the child in relation to all children of this age, not just their present class or even school. And the teachers could rate the children as well above average through to well below average. And I collapse the above average and the below average categories to have adequate cell sizes for modelling, and this results in the sample having 43% of children who were believed to be above average by their teacher, 40% average, and 17% below average. The teachers were also asked, in this child's class, are there within class subject groups for maths? They could answer yes or no. If they said yes, they were asked, which group is this child in for maths? Highest, middle, or lowest? And so this results in the information that 34% of the children were in the highest group, 35% in the middle, 14% in the lowest, and 17% not grouped in class for maths. So this is the basic raw relationship between the maths ability group at 7 and maths self-concept at 11. So 5% of the children who were in the highest group at 7 had negative maths self-concept at 11, and this compares to 25% of children in the lowest group. And children who are not grouped are sort of somewhere in the middle, just below those in the middle group. This is the basic relationship between teachers' judgment about children's maths ability and attainment at 7 and their maths self-concept at 11. So among the children whose teachers believed them to be above average at maths, at 7, 3% have negative maths self-concept at 11, compared to 26% of the children whose teachers believed them to be below average. So to look further at this, I use a series of logistic regressions. The outcome is binary. It's whether the child have negative maths self-concept at 11 or not. I'm going to present to you model predicted probabilities from the logistic regressions. And next today, I'm going to present the findings from the basic model, which just has those two key predictors together. So maths ability group at 7 and teacher judgment of maths at 7. And this is going to tell us whether each has a relationship with later maths self-concept at 11, accounting for the other. So we see here that controlling for maths ability group at 7, lower teacher judgment of maths at 7 predicts negative maths self-concept at 11. So up the side of the graph here, we've got the probability of negative maths self-concept at 11, and these are children who were judged above average by their teacher, and they have a much lower probability than the children who were judged below average by their teacher, who have a sort of over 20% probability controlling for maths ability group. When we control for the teacher beliefs at 7, we see that maths ability group at 7 also still predicts negative maths self-concept at 11. So again, this is the probability of negative maths self-concept up the side, and these are the children in the highest group. They have a much lower probability than children in the lowest group, and still the children who are not grouped are sort of somewhere around the middle. But of course, this is quite basic, and this might be simply because ability groupings and teacher judgments are somehow accurate, and children who are less good at maths are rated below average by their teachers and placed in lower groups. And then accurately, they have negative maths self-concept, and there may be confounding third factors. So to address this, I add controls to estimate the independent relationships between maths self-concept and maths ability group, math teacher judgments respectively. And my key control is a maths cognitive test score at 7. So this is the NFVR progress in maths test. So by using this in my models, I'm looking at whether the subsequent self-concept of children with the same measured maths skill at 7 who were placed in different groups or judged differently at the same age have different self-concept. And this test was administered outside of the school context. It was administered by MCS interviewers in children's homes earlier in the same survey wave that teachers had their survey. So in order to condition my analyses on the maths cognitive test score, I need there to be children with each level of teacher judgment and in each ability group across the range of scores. And these graphs show that that indeed is the case. They exist. So if we look here, this is children's groups, and this is the whole sample. And this is the maths test score along the bottom. And this is the proportion of children falling into that group with each score. And we see that among children in the highest ability group, it is the case that more of them have higher scores, but there are also some low scoring children in that group. And we see the same for children in the lowest group. So there are children across the range of scores in the lowest group, including some high scorers. And if we look at the sort of mid-scoring children, we can see they're fairly equally distributed across groups. And it's the same thing for girls and for boys if we look at them separately. And it's the same thing for judgment. So here we see, if we look, say, at the mid-scorers, there's a distribution across scores and across judgments. Same for girls and same for boys. The other factors that I control for are, of course, whether the child is reported to be a boy or a girl by their parents at age 7, for whether languages additional to English are spoken at home at age 7, for children's reported ethnic group, which is collapsed into 8 categories, for children's month of birth. I also control for a naming vocabulary cognitive test score from when children were age 5, for their pattern construction test score that they took at age 5, and picture similarity test score from age 5. I control for the literacy ability group that children are in at age 7, for their teachers' judgment of their reading ability and attainment, and for whether their teacher reports them ever being attributed special educational needs or disabilities. I control also at wave 7 for family income, for mother's highest education level, of course, as I say, for maths cognitive test score, but also for reading cognitive test score. I control for whether the children's parent reports them having difficulties with maths and whether their parent reports them having difficulties with reading. And I control for whether the parent reports them having help with maths at home or help with reading at home. So, controlling for the maths cognitive test score and all these other factors, teacher judgment of maths ability at 7 still predicts maths self-concept at 11. So we can see there's not very much attenuation going on here. So the children judged below average by their teacher at 7 still have about a 20% predicted probability of negative maths self-concept at 11, even conditional on the maths test score at 7. And for so-called ability group at 7, we say that group at 7 still predicts negative maths self-concept at 11 with all the controls, including the maths cognitive test score. Here's the children in the highest group at 7, low probability at 11. Those in the lowest group at 7 are higher probability. So far, this is congruent with previous research that indicates that so-called ability grouping stratifies and that teacher judgment influences trajectories. So next I look beneath the aggregate. I look at how relationships between teacher judgment at 7 and ability group at 7 respectively, and later self-concept, differ for children with varying concurrent math skills according to the cognitive test at 7, and for girls and boys. So to do this, I add respective interactions to make 2 extended versions of the full model with controls. The first interaction interacts maths ability group at 7 with maths cognitive test score at 7. And the second interacts maths teacher judgment at 7 with maths cognitive test score at 7. I do this for all children and then separately for girls and for boys. So this shows the interaction of teacher judgment with maths score. So let me explain what's going on in these graphs. So this graph is just girls and this is just boys separately. Up the side of the graph here, we've got the probability of negative maths self-concept at 11, of saying they're not good at maths. And along the bottom here, we've got the maths test score. And so what we can see is that low scoring girls, so that is the dashed green line. That's the dashed green line is girls who are judged below average by their teacher at 7, and the non-dashed blue line is the girls who are judged above average by their teacher at 7. So we see that all low scoring girls and all girls judged below average by their teacher at 7 have a higher chance of later negative maths self-concept. So that's even these girls who are higher scoring at 7, but judged negatively by their teacher go on to have later negative maths self-concept. In contrast, for boys, we see that all high scoring boys and all boys judged above average by their teacher at 7 have low chances of later negative maths self-concept. So even the boys who scored low at 7, who were judged and believed to be above average by their teacher at 7, have low chances of negative self-concept at 11. And this is the interaction of group with maths score. So again, I'll just explain what these graphs are showing. So this is girls, this is boys. The blue undashed line is the children who are in the highest ability group at 7, and the green dashed line is children who are in the lowest ability group at 7. And we see that only high scoring girls placed in the highest ability group at 7 have a low probability of negative maths self-concept at 11. Girls who are placed in the highest group at 7, who scored lower on the math test, have increased chances of negative self-concept. So they are little fish in big ponds, inverting the big fish, little pond effect. In contrast, all boys placed in the highest ability group at 7 have low probability of negative maths self-concept at 11. So for them, this is consistent with labelling effects. Even low-scoring boys, if they were placed in the highest ability group, go on to have positive maths self-concept. So I do various sort of checks on alternative specifications of my models, including running all the interactive models without controls, adjusting the math score range that it's included, adding low scoring outliers back in, taking them out, using a categorical recoding of the math score variable, trying linear probability rather than logistic models, and conducting analyses without survey weights because the analytical sample is not a complete representation of the full wave 5 sample. And all my results are consistent using these alternative specifications. So to summarize so far, going back to the original questions, is the maths in-class ability group within which a child is placed at age 7 related to their maths self-concept at 11? Well, yes, there's a strong association. So with all controls, children in the lowest ability group have higher odds of negative self-concept compared to those in the highest group. And they have corresponding predicted probabilities of 15% compared to 7% of saying they're not good at maths. Secondly, does the judgment by their class teacher of a child's maths ability and attainment at age 7 relate to the child's maths self-concept at 11? And again, yes, this association is substantial. After including all controls, children judged below average have odds much higher than those judged above average of reporting not being good at maths at 11. And again, this is a substantive difference in predicted probabilities of 20% compared to 7%. Thirdly and fourthly, do these relationships vary by a child's early concurrent math skill as measured by the maths cognitive test? And do they vary by gender? And yes, there are significant variations beneath the aggregate. So all boys placed in the top group at 7 had very low chances of negative math self-concept at 11, regardless of their math skills at 7. But in contrast, only high-scoring girls placed in the highest ability group had positive math self-concept at 11. Girls with lower scores at 7 who were placed in the top group were more likely to have later negative math self-concept. And additionally, all girls judged below average by their teacher at 7 were more likely to have negative maths self-concept at 11, even if they scored high marks on the maths cognitive test. So, what factors might feed into these gender differences? So Hallam and colleagues talk about how high group placement is not uniformly a positive experience, that there's pressure and negative social processes for high group children. And Bowler talks about how there's an air of urgency, of competition and confrontation in the higher groups, and talks about lost and unhappy girls. And Bowler argues, in fact, that the gender imbalance in the school mathematics system may be caused by certain features of the top set environment. Carey and colleagues more recently sort of concur with this, and they report girls feeling relief on moving away from top group placement, away from the pressure and the rush. So boys at the aggregate level tend to have more positive maths self-concept than girls, and this is supported by wider stereotypes. So the possibility is that girls' maths self-concept is less established or less of a given, and that it may be more or differently vulnerable to environmental influences. Of course, there's many limitations to this work, and here's a few. So firstly, as with any test, how well does the maths cognitive test at 7 measure children's skills? I mean, it's a sort of tested and validated test, but there's always error and always caveats to using these tests. It's not possible to include more detail on school and class composition into the analyses at the moment, because the mean number of children per school is 2. However, potentially this might be something that can be done in the future if the MCS is linked to full school year groups in the NPD. Of course, I'm just using here one question that's measuring one facet of math self-concept, unlike other work that uses scales and sort of multi-question constructs. On the other hand, this sort of adds a certain simplicity to what I'm doing. So limitation, but you could argue for the simplicity. These are, of course, high-level descriptive associations. I can't examine mechanisms and mediators between 7 and 11, given the shape and the timing of the data. And lastly, the MCS children were 7 in 2008, of course, and 11 in 2012. So these findings need to be interpreted within the policy and practice context of the time. Saying that, on the plus side, the MCS is a continuing longitudinal study. So we can continue to examine the impact of these early experiences and environment on the life course and future self-concept. And I would also argue very strongly that findings can still be relevant to current policymaking, that we should continue to examine and learn from the past. So what next? So I'm now going to briefly present some very early examinations of what happens next and look at the following questions. So firstly, do ability group at 7 and teacher judgment at 7 continue to predict maths self-concept at age 14 once children are well into secondary school? Do ability group at 11 and teacher judgment at 11 predict maths self-concept at 14? And very tentatively, I'm going to start to explore how group at 7 and 11 and judgment at 7 and 11 relate as predictors of later self-concepts at 14. So as I say, this is preliminary work in progress. And one thing to highlight is that the sample I'm using now is smaller because it incorporates non-response to the teacher survey when children were 7, non-response to the teacher survey at 11, attrition to wave 6 when the children were 14. And so the key thing to highlight there is that the subsample here is slightly more advantaged than the full age 14 sample or the sample with the age 11 outcome, according to factors like income, family income, mother's education, and also in terms of their ability group placement at 7 and teacher judgment. So they're slightly more likely to have been in the higher group and to have been judged more favourably. So as I say, the sample is a subset of those in the existing published research who also have information from a teacher survey at age 11 on maths group and teacher judgment and on their maths self-concept at 14. So this is about 3,000 children now. So very usefully, the exact same question on teacher beliefs judgment of maths is repeated at 11. So the child's class teacher at 11 receives the same set of questions as the class teacher at 7. And the question on maths self-concepts is also repeated exactly at 14. The difference, I'm going to talk about this a bit more in a few slides, is that at age 11, the teachers are not asked about in-class groups. They're asked about whether children are set for maths, which is a somewhat different practice. I'm currently not using weights in what I'm about to show you. I need to do lots more checks on alternative specifications, figure out what I'm doing about weights and standard errors, think more about my models, controls, how I'm coding things and so on. So as I say, this is very sort of initial and exploratory. This just initially is to show you the proportion of the sample with negative math self-concept at 11 versus 14. This is age 11, this is age 14, this is all the children, boys and girls. And what you can see is that overall, more children have negative math self-concept at 14 than did at 11. And you can see that still at age 14, girls are more likely than boys. Nearly 25% of the sample girls at 14 said they were not good at maths. And 80% of the children in the sample have the same reported maths self-concept between 11 and 14. But some children change from one point to the next. So these are children who went from positive maths self-concept at 11 to negative at age 14, so about 14% of the whole sample. And these are children who went from negative to positive, about 6% of the sample. And you can see that girls are slightly more likely than boys to switch. So now I'm just going to show some very early work that shows age 14 maths self-concept as the outcome. So these are the same models and controls that we use for the age 11 self-concept outcome, but instead of age 11 maths self-concept, we have age 14 maths self-concept. And what we see is that age 14 maths self-concept is still predicted by both age 7 maths in-class ability group and age 7 teacher judgment of maths. So this is the probability of negative maths self-concept at 14. These are the children who are in the highest maths ability group at 7. They have a lower probability than children in the lowest group. And we see this pattern again with the teacher beliefs at 7 being related to the maths self-concept at age 14. So as I say, there is also some information on ability groups at age 11 when children are in the last year of primary school. And this is the proportion of children who were in each maths ability group at age 7 and age 11. And so what you can see here is that similar proportions at age 7 were in the highest group and in the lowest group. But more children are reported as not being grouped at 11. But just to emphasize that these are somewhat different practices, the question about in-class grouping for maths wasn't asked at 11, so we don't have the information on that. This was the question about whether children were set for maths at 11. So at the moment, I'm just thinking about how to interpret this, how useful it is, and unpicking all of that. And so this is the proportion of sample children who are judged above average, average, or below average at maths by their class teacher at 11 and by their class teacher at 7. So this is age 7, above average below. This is age 11, above average below. And we see a similar upwardly skewed distribution at both ages. And the difference is that slightly more sample children are judged above average at 11 than at 7, over 50%. So if we look using the same models with the same controls, but using the age 11 teacher judgment and age 11 ability group at how they predict maths self-concept at 14, we can see that there are relationships here as well. So being in the highest maths set at 11 is related to a lower chance of negative self-concept at 14. And the teacher beliefs about the child at 11 is also related to maths self-concept at 14. So these are the kids whose teachers believe them to be above average when they're 11 at the end of primary school. They have a low probability of negative self-concept at 14. These are the children whose teachers believe them to be below average, much higher. But then sort of an obvious question from this is whether this is just showing the same thing as the research with the age 7 predictors. So does ability group and teacher judgment measured at 11 just continue or mirror the group placement and the teacher judgment at 7? Well, not entirely, because some children do shift groups and teacher judgment levels. So 39% of the sample children are in the same ability group position at 7 and 11. So just to emphasize again that these are slightly different practices, and that'll be one of the reasons for the rather low correspondence. These are sample children, just to give you a taste, who move in or out of the highest maths ability group between 7 and 11. So some children go from a lower group into the highest group at 11, about 15% of children, and some go from the highest group at 7 down to a lower group at 11, about 70% of children. 67% of the sample children have the same judgment from their class teacher at 7 and their class teacher at 11. But that does leave 33% of children who've had a shift between those points. So we can see here that about 5% of children have fallen to be judged below average by their age 11 teacher. About 6% of children have risen to be judged to be judged average by their teacher at 11. 8% of children have fallen from being judged above average to being judged average. But the highest proportion of children have risen, as we saw in the previous graph, the hint of this. So about 14% of children have gone from being judged at a lower level to being judged above average by their teacher in the last year of school. So lastly, I'm just going to show a quick initial preliminary look at how group at 7 and 11 and judgment at 7 and 11 relate as predictors of self-concept at 14. So in what I'm about to show you, I'm still using the controls at age 5 and age 7 as per the previous analyses of self-concept at 11. So just as a reminder, that covered the math score at 7, other cognitive tests at 5 and 7, demographic factors, other home and school factors. So the key things here, so the outcome here is the negative maths self-concept at age 14, saying that they're not good at maths. And again, up the side here, we've got the probability of this negative maths self-concept at 14. And the key thing here is that children who are not in the highest group at 7, nor in the highest group at 11, so they're in a lower position at both time points, have the highest probability of negative maths self-concept at age 14. And down here, children who are in the highest group at 7 and the highest group at 11 have the lowest probability of negative self-concept at 14. And the children with some combo of the two who shifted between the two ages are there somewhere in the middle. In terms of the combinations of teacher judgment at age 7 and 11, we see here that children whose teachers, and again, just as a reminder, this is controlling for all the other factors, including math test score at 7. So the children whose teachers believe them to be below average at 7 and below average at 11, those two separate teachers, have a nearly 40% predicted probability of negative math self-concept at age 14. And this falls through the different sort of combinations of age 7 and age 11 teacher judgments, down to these children who had teachers who believed them to be above average at age 7 and age 11, and they have much lower probability of later negative math self-concept. So, in summary, on these early indications from the extension of the work, maths ability group at 7 is associated with math self-concept at 14 still, controlling for potential confounders, including math cognitive test at 7. And teacher judgment of maths at age 7 is also associated with maths self-concept at 14, again controlling for the potential confounders, including the math test at 7. The interplay with grouping at 11 and teacher judgment at 11 remain to be untangled further, but these early indications that I've just shown you indicate that both may play a part. So thank you very much for watching and for listening, and any questions and comments would be very welcome.
Thank you so very much, Tammy, for a very interesting talk, very interesting results. Yes, please put any questions in the chat or unmute yourself. Let me look first at, are there any burning questions? James, you got your video on. Would you like to go first?
Oh, thank you. I think this is fascinating. This is really important to establish that logical train between the teacher's estimation, the student's self-estimation, and the eventual self-identification in math ability. So this is really amazing to see. So thank you. And I'm wondering, and I might have missed this, but is there some objective criteria as well on like performance on exams? And it seems like, yeah, so I apologize if I missed that already, but if you speak to that briefly.
No, really good question. So the MCS does have linked data on children's Key Stage 1 tests and Key Stage 2, and it would be great to be able to use the Key Stage 2 maths test in this research. The reason I haven't is basically entirely pragmatic, that I did this work during COVID lockdown last year, and I kind of lost access to secure data, and I kind of on balance decided that there was kind of enough substantially to be in the paper, just kind of looking at these links to self-concept and following this through. But I agree that it would be definitely something for the future to look at how that interplays and to look at that as an outcome and the relationships.
Thank you.
Thanks, James, for your question. We've got a couple of questions in the chat, more about clarification. So one of them is from Deborah asking a clarification around, in the UK, how often are these groupings reassessed, really?
Yeah, I mean, that's a really good question. And I don't think we actually have at scale great information on that at the moment. So as I showed there is movement between sort of what we can see in the MCS between age 7 and age 11, and there's also movement sort of in the literacy group. But I mean, if anybody can correct me and say that I'm wrong about this, that would be great. But to my knowledge, we don't know about that at scale. There is sort of qualitative work talking about how groupings are formed and the sort of pressures that play into that and so on. But I can't answer that question. And I think it's a real kind of gap in the evidence. I think what I personally would really like is if in the National Pupil Database, this information was collected, at least maybe for a sample, so that we had a sense of how much movement there was, and then we could look at sort of predictors of movement or of children who just stay in the one place. But I can't entirely answer the question, but it's definitely something that would be really useful to know.
Absolutely. Kathy was asking around, whether male teachers were included in your sample as well, or only female, but teachers.
Yeah, so in the MCS, there's only 4% of the teachers who are male. I'm not 100% sure if that's exactly representative of the population of teachers at that time, because the MCS was sort of sampled to be representative, but it's more urban than rural because of sort of sample considerations and various other things. So were there only 4% male year 7 teachers at the time? I think there's other evidence on that, but I can't remember off the top of my head. But in practice, there's too few for me to do anything with it in terms of sort of interactions with the teacher being male or female in the data.
Yeah, I'm going to ask my question because it follows up on that kind of sample in terms of, do you know anything around teacher experience and whether that would influence your findings in terms of how they see children?
Yeah, I have actually looked at that before. In a previous paper where I was looking at stereotyping of children, where I found biases according to, so for maths, biases according to gender, and also biases according to ethnicity and home language, and various other things. And there is information in the MTS asking about years of experience, and I didn't actually find that was something that made any difference. In terms of this work, in terms of the kind of future impact, I haven't looked at that yet, but I was actually kind of surprised that just kind of looking at the stereotyping, that the experience didn't seem to interact, because there is other research that indicates that it does, isn't there? So, but no, it didn't seem to in this sample. Okay, great.
It's good to know. Gary's asking as well is that whether any of this research, sorry, I'm going to ask read the question. Is there any predictors or research how this self-concepts might impact on GCSE outcome scores and final exam grades?
Yeah, I mean, there is. I mean, there's actually other research using the MCS or the British Cohort Study. If I'm remembering correctly, there's a paper by Morag Henderson and Kirsty Hansen that looks at this. So have a look at that. And there's there's other papers as well. I think Alice Sullivan has one. So there's quite a few papers using the cohort studies. And obviously, I'd sort of like to link this all up as I take the research forward, data allowing.
That's great. Caroline is asking around, do you have any thoughts as to why more children have negative concepts of their maths ability at age 14 than 11 in terms of what happens?
Yeah, I mean, I think it's sort of, well, it's obviously a sort of cumulative thing, isn't it? And I think we saw sort of that the maths grouping at 11 was associated with the concept at 14, and the teacher beliefs were associated. And I think all these environmental influences are continuing to have a cumulative effect that builds at different ages, and sort of just kind of in wider society, just the stereotypes in terms of sort of maths being difficult, or maths only being for sort of certain people who are good at maths. And then you've also got the sort of inverse effects of self-concept, haven't you, where if you are good at sort of language related or literacy related subjects, you're more likely to think that you're bad at maths related subjects. So I think that's a component of it as well, where people sort of, kids start to develop this sense of sort of their strengths, so not necessarily sort of accurate, because it's not necessarily accurate that if you're good at reading and literacy and English, you're not good at maths, but this all kind of builds up and kind of channels children more narrowly as they age.
Yeah, I think I was going to ask you about that in terms of, you've got the MCLS data. Do you find the same effects for like gender, etc., for the reading outcomes as well, or have you not looked at that?
Yeah, no, that's I have looked at that. So I've looked at it sort of from various angles. I mean, first I looked at it just using sort of reading self-concept as an alternative to math self-concept as my outcome, using the same predictors, just to check that these were sort of domain specific effects rather than being a kind of general self-efficacy or self-concept effect. And that was a useful check, because I did find that it definitely is domain specific. So, the maths ability group at 7 and the teacher beliefs at 7 don't relate to self-concept in language and reading and literacy. And then I've sort of flipped it entirely and looked at whether group for literacy and teacher judgment of reading are associated with reading self-concept. And what I find is that there are some associations, but they are weaker. And I think that's for a couple of reasons. I think firstly, well, sort of overlapping reasons. So firstly, the measures in the MCS are kind of less specific and more fuzzy for sort of literacy and language and reading and so on, and they're less kind of clearly defined. So I think partly it's to do with measurement, but I think also it's partly to do with the fact that in real life they're wider and more overlapping, whereas maths is kind of a bit more domain specific, so it's kind of easier to map, and conceptually it's more sort of distinct. And then additionally, I think there's quite a lot of evidence that sort of language and reading and those skills are more influenced by the home environment, whereas maths is more influenced by the school environment. in which case it would make sense that I see that the maths groups and the maths teacher input and beliefs are more associated with maths concept, whereas sort of reading isn't so much, because they're getting potentially more input and more messages about that from home.
Yeah, it makes it. That's really interesting to know, actually, that it's domain specific. I think it links to Paul's question around P's question around did you consider or do you have a measure of anxiety for children? Because in my experience, children who are behind become very anxious, and this seems to hinder the process in maths as well. And I think it's interesting to indeed around thinking what are factors that could be resilience or protective factors, or factors that don't.
Yeah, no, that's a really good question. And I'm going to sort of look more about the sort of mediators kind of in this work, looking at the later sort of secondary school outcomes, because there is some information from age 11 on more of this kind of thing. And then also if I sort of go forward to the next wave of the MTS at age 17, then I've got information about well-being and these kind of factors at age 14 to use. So yeah, definitely, I haven't yet, but definitely it would be good to look at anxiety and so on as mediators and trying to unpick how this is all interplaying.
Yeah, absolutely. Because Paul's question is around, how do these kind of results and incidences compare to school children in other countries? I don't know whether you've got any knowledge around that.
Oh, okay, that's interesting. In terms of sort of the actual kind of cognitive processes, or in terms of the
negative maths concept, like are we more in the UK, are children more negative in terms of their self-concept related to maths compared to other countries?
I don't know, actually. That's a really good question, because obviously, yeah, at a very high level, it would be interesting to look at that in terms of the policies and the practices in different countries. I'm sure there is literature on that, but I don't know off the top of my head, I'm afraid.
That's great. Sorry, I'm just trying to read as well. Yeah, thanks, James. Yeah, I think it's indeed very fascinating results and talk. I was also wondering, from your research, what would your suggestions be? Because I know you're interested in policies as well as in, what happens in the classroom. So what would be your advice from your research so far for educators or policymakers?
Yeah, I mean, I think so. The findings on ability grouping really just sort of add weight to the existing research that indicates that so-called ability grouping really stratifies children's trajectories and sort of contributes to cumulative advantage and disadvantage, and really does have sort of substantially significant as well as statistically significant effects on children's trajectories. And therefore, just simply, it really should be enormously rethought whether it should be used at all in primary school. I mean, I would basically say it shouldn't, but I know it's not quite that simple. In terms of the findings on teacher beliefs, I think they sort of point to teacher sort of thinking styles and belief styles, and then the practices that are associated with the different styles as kind of points for intervention as well. And one of the things that I didn't really get into just because of time with this is obviously the question is that sort of raised by the findings is, are the teacher judgments and beliefs something that, because there's sort of two kids on average per school in the MTS. So it might be that the children who are judged above and who are judged below average are kind of unlucky that they have a teacher with a more negative thinking style. Because we saw that sort of by the distribution, this isn't a very logical kind of, it's not a normal distribution, when most children are judged above average and then some are below and some are above. It's more a kind of cognitive tendency and leaning on the part of the teacher. But then the question is that we can't know from the data, is the teacher judging this particular child negatively in their class and other children positively, or do they have an overall kind of negative thinking style and associated behaviours? And there's some work by Ruby Davis, who I think was at the IOE at one point and is now at Auckland, looking at how teachers do have sort of tendencies to being high expectation or low expectation teachers. So if this is kind of picking up more that, the kids with the positive with the associated positive beliefs have the high expectation teachers, or even if it is picking up the teachers having this negative expectation of the particular child, it really does point to sort of teacher thinking styles and beliefs as a sort of lever for intervention as well, that could make a difference to children.
Yeah, absolutely. Well, thanks very much for that, Tammy. I think, you know, we've got all the questions have been answered. So thanks very much. Thanks again for a very fascinating talk with results. Thank you all people in the audience who are here with us today. As mentioned, this was the final one for this academic year, but we'll definitely be in touch in September with a new schedule for the Centre of Educational Neuroscience seminar talks. So thank you very much from me and have a good evening. Take care. Bye-bye.